Hello, my dear student. I am going to discuss about Edexcel IGCSE Certificate in Physics, Forces and Shape. Edexcel IGCSE Physics book, pages 18 to 27. Content applying to triple science only is shown in the red type on the next slide and indicated on the subsequent slide by triple only. I am Jahangir. I am a physics teacher. My contact number is 01717979515. Edexcel specification for the chapter Unit 1 Forces and Motion, Chapter 2 Forces and Shape. After finishing this chapter, you can describe the effect of forces between bodies such as change in speed, shape or direction. Identify different types of forces such as gravitational force, electrostatic force. Understand how vector quantities differ from the scalar quantities. Understand that force is a vector quantity. Calculate the resultant force of forces that act along a line. Know that friction is a force that opposes motion. Practical. Investigate how extension varies with applied forces for helical spring, metal wires and rubber bands. Know that initial linear region of force extension graph is associated with Hooke's law. Describe elastic behavior as the ability of a material to recover its original shape after the forces causing deformation have been removed. First, we should start from force. What is force? The external cause which changes or tends to change the state of motion of an object or the direction of motion of an object or the shape and size of the object is called force. A force is a push or a pull. A force can cause an object to speed up, slow down, change direction, change shape. Forces is measured in Newton. Newton is the SI unit of force. Force is measured with a Newton meter. There are several types of Newton meter here. Some types of force. First, gravitational force. What is gravitational force? The mutual attractive force exerted between bodies because of their masses is called gravitational force. This force increases if either or both of the masses is increased and decreases if they are moved further apart. Weight is the gravitational force of Earth on an object. We can calculate weight by using the following formula: weight equal to mass into gravitational field strength, small g. So W equals to m into small g. Bathroom scale measure weight. A mass of 1 kg weight about 10 Newton. A stone is about 63 Newton. Now normal reaction force. What is normal reaction force? This is a repulsive force that stops two touching bodies moving into each other. So the word normal means this force acts at 90 degrees to the surface of the bodies. So when an object is placed on a surface, then surface will give an upward force to the solid object which is exactly equal to the weight of the object, but it acts upward, that means opposite to the direction of weight force. It caused by the repulsive molecular forces. Look at the diagram here. Normal reaction forces, so it acts upward, opposite direction of the weight. The two upward reaction forces on the tires balance the downwards weight of the car. Now friction. What is friction? Friction, this is the force that opposes the motion. The kinetic energy of the moving object is converted to heat energy by the force of friction. Friction is needed for racing car to grip the road, and friction is needed for walking. So what is friction? When a body moves or tends to move over another body or any surface, then a resistive force is developed between two surfaces in contact, which is known as friction. This resistive force is called frictional force. Look at the diagram here. The purple color object moves or tries to move right direction over a green colored surface. Then there produces a resistive force between two surfaces. That force is known as frictional force. Now, types of frictional force. Generally, there are four types of friction: static friction, sliding friction, rolling friction, fluid friction. Look at the diagram here. Static friction is the friction between two surfaces that are not moving relatively to each other. Sliding friction is the friction where an object slides or rubs against another surface. Rolling friction is the friction between rolling object and surface. That is called rolling on. Fluid friction, when an object in a fluid, that means a liquid or gas, the friction acts is called fluid friction. Look at the diagram below. The swimmer, a person, swim forward direction over a water medium. Then water molecules tries to opposes the movement of the person. That friction is known as fluid friction. Now, air resistance or drag force. This is a force that opposes the movement of the objects through air. Drag is a more general term used for opposition force in any gas or liquid. Objects are often streamlined to reduce the force. So, what is air resistance? When any solid object moves through air medium, then molecules of the air gives an opposing force or resistive force against the direction of motion. That force is known as air resistance. It is a streamlined curve. A parachute maximizes drag force. Now, upthrust force. What is upthrust force? This is a force experienced by objects when they are placed into a fluid like liquid or gas. Look at the diagram below. When any object is submerged inside a liquid completely or partially, then molecules of the liquid or fluid, liquid or gas, tries to give an upward force to the solid object. That force is known as upthrust force. An object will float on the fluid if the upthrust force equals its weight. A hot air balloon rises when the upthrust force from the surrounding air is greater than the balloon's weight. Now, magnetic force, the attractive or repulsive force between magnets and magnetic materials, but also the force that allows electric motors to work, is called magnetic force. So, magnetic force are two types. One is attractive, another is repulsive. When unlike pole like south and north comes closer, then they attract each other. On the other hand, when same or like poles come closer, they repel each other. That means unlike pole attract each other and same poles or like poles repel each other. Now, electrostatic force. Attractive or repulsive force due to the bodies being charged is called electrostatic force. Electrostatic force causes the girls here to rise when they touch the Van der Graaf generator. It is an amazing experience. Look at the girls here. The girls here to rise when they touch the Van der Graaf generator, because Van der Graaf charge, it is a charge generator. When she touches the sphere, metallic sphere of the Van der Graaf generator, charge generator, then charges flow to her body and also her hair, then same type charges, and they repel each other. That's why the girls here to rise when they touch the Van der Graaf generator. Forces you should be aware of include weight. So weight, the name given to the force of gravity on mass. Electrostatic force, the force between two charges. Thrust, a force pushing an object upward, such as a force from a car engine. It is a thrust force. Air resistance or drag, the friction of the air on a moving object. Upthrust, a force of fluid such as water pushing an object upward, making it flow. Compression, the force that is squashing an object. Tension, the force that is stretching an object. Reaction force, a force due to contact between two objects. Choose appropriate words to fill in the gaps below. A dash is a push or pull. Dash is a push or pull. A force can cause an object to dash, to change shape. A force is a push or pull. So a force is a push or a pull. A force can cause an object accelerate or change shape. Force is measured in Newton with Newton meter. So force is measured in Newton with Newton meter. So unit of force is Newton. There are many types of force. Contact force occurs when two bodies touch each other. So contact force is the force when two bodies touches each other. Friction is a force that opposes the motion of a body relative to another. It causes by the attractive forces between molecules. Now, vectors and scalars. Considering the aspect of direction, all quantities of physical world can be divided into two groups. One is scalar quantity, another is vector quantity. First, what is scalar quantity? The physical quantities which can be fully expressed by magnitude only are called scalar quantity. What is the term magnitude? Magnitude means a value or number. Like 5 kg, 5 is the magnitude and kg is the unit of that quantity. So scalar quantity is the physical quantities which can be fully expressed by magnitude only are called scalar quantity. Like length, mass, speed, work, energy, time, temperature, etc. are examples of scalar quantity. So scalar quantity has only magnitude, no direction. On the other hand, vector quantity, the physical quantities which need both magnitude and direction to be fully expressed are called vector quantities. Displacement, weight, velocity, acceleration, force, all type of force. electric intensity, magnetic intensity, all are the examples of vector quantity. So vector quantity is the physical quantity which have both magnitude and direction. Without direction, vector quantity cannot be understandable. So a summary of this scalar and vector. Scalar quantities has magnitude, vector quantities have both magnitude and direction. So there are a list of scalar and vector quantity. Scalar quantity: distance, unit meter; speed, unit meter per second; time, unit second; mass, unit kg; temperature, unit Kelvin; pressure, Pascal or Newton per meter square unit; kinetic energy, joule; gravitational potential energy, joule; work, joule; power, joule per second or watt, joule per second or watt, current, unit ampere; potential difference, unit volt; resistance, unit ohm. On the other hand, vector quantity, example: displacement, velocity, acceleration, weight, moment, momentum is a vector quantity, unit kg meter per second. This is the example of vector quantity. Now, representing vectors. An arrowed straight line is used to represent a vector quantity. Displacement 50 meter east. So red colored line, straight line, arrowed straight line is used to represent a vector quantity. So arrow indicates the direction and the length of the line proportional to the magnitude of the vector quantity. So displacement 25 meter at 45 degree north of east. Addition of vectors. Here an object, here there are two forces act on that object in the same direction, that means right direction, 4 Newton and 6 Newton. So resultant vector will be 10 Newton in the right direction because two forces act in the same direction. On the other hand, the original vector are called component vectors. The 4 and 6 are the component of the resultant vector. The final overall vector is called resultant vector. So if 6 Newton acts on the right direction and 4 Newton acts on the left direction, then the resultant vector will be 2 Newton in the right direction, towards the right direction. Now resultant vector. When forces act in the same line, we can just add or subtract their magnitude to find the net force. So when forces act in the same line, we can just add or subtract their magnitude to find out the net force. Case 1, look at the diagram here. So force A pushing the object the right direction, force A equal to 5 Newton. On the other hand, force B pulling the object to the right direction. So force B 10 Newton equal to, so resultant force 5 plus 10, 15 Newton to the right direction. Case 2, force X pulling towards west 3 Newton, and force Y pulling towards east 5 Newton. So resultant force moves the body towards east with a force of 2 Newton. Case 3, Case 3. 2 Newton force acts right direction and 2 Newton force in the left direction. So resultant force will be 0. Body will not move because forces are balanced. Forces are balanced here. Resultant force. So look at the diagram here. Total overall acting force. There are several forces acting on the car here. Yellow color driving force acts right direction. That means engine gives the driving force, and friction force, red color one, is the friction force, acts where the wheels of the car touches the road. It is one kind of contact force. And air resistance, purple color air resistance, and reaction force, blue color reaction force, upward normal reaction force. Try to solve this one. So number 4, driving force. Number 5, weight of the car. Number 3, normal reaction force. Normal reaction force. And number 2, frictional force or friction. And number 1, air resistance. This example is very important for IGCSE O-level physics. Very important. Now, more about resultant force. So, a number of forces acting on a body may be replaced by a single force which has the same effect on the body as the original forces all acting together. That force is known as resultant force. Look at the diagram here. A box, 2 forces acting on the object in the right direction, 3 Newton and 2 Newton. So the overall force is called resultant force. So in the example opposite, 5 Newton is the resultant force of the 3 Newton and 2 Newton forces. Now determine the resultant force in the case below. Example number 1. Here resultant force will be 6 Newton to the right direction, 10 Newton. So 4 Newton and 6 Newton. So resultant force will be 10 Newton to the right direction, On the other hand, question number 2, 4 Newton acts right direction and 3 Newton force acts left direction. So resultant force will be 1 Newton to the right direction. Question number 3, 7 Newton acts downwards and 3 Newton force acts upward. So resultant force 4 Newton downwards. Question number 4, 2 Newton force acts downwards and 6 Newton force acts upward. So resultant force will be 4 Newton upward. Question number 5, 4 Newton force acts downwards and 4 Newton force acts upward. So there is no resultant force in this case. Now look at the diagram. 60 Newton and 30 Newton both acts right direction. So resultant force will be 90 Newton to the right. In the second diagram, 30 Newton force acts right direction and 10 Newton force acts left direction. So resultant force will be 20 Newton to the right direction. Now third example, a black colored spherical object. It is an object, black color. Force acting a right direction Fr equal to 1600 Newton and force acting left direction 1600 Newton. So resultant force 1600 Newton minus 1600 Newton left. So 0 Newton. So resultant force is 0 here. Now example number A, 20 Newton force acts right direction. Also 10 Newton force acts right direction. So resultant force 30 Newton. Question number B, 40 Newton force acts right direction and 20 Newton force acts left direction. So resultant force 20 Newton to the right direction. Question number C, 25 Newton acts right direction and 25 Newton force acts left direction. So resultant force is 0, so 0 resultant force. Try to solve situation A, situation B, and situation C and situation D. It is the challenge for you. Try to solve these 4 situations and write the answer in the comment section. I will feedback you. Okay, next one. Find net forces from the following diagram. It is also a challenge for you. This type question will come your Edexcel IGCSE physics or Cambridge IGCSE physics, AQA O-level physics. So practice all the question A, B, C, D, E, F, G. Try yourself. Now next one. Resultant force and motion. If the resultant force is 0, that means balanced. If the forces are in balance, then object velocity stays same, including staying stationary. If there is no unbalanced force, then object will remain stationary or it moves with constant velocity. In the direction of object is moving, object accelerates. In the opposite direction, if a resultant force in the direction of the object is moving, the object accelerates. If the direction of the resultant force is opposite direction in which the object is moving, then object decelerates. Very important thing. Yeah. Now example 1 and 2. The box will move when the man's push force is greater than the friction force. So if man's pushing force is greater than the friction force, then the box will move forward. Look at the second example. The plane will accelerate provided that the engine force is greater than the drag force. Now example number 3 and 4. The brakes exert a resultant force in the opposite direction to the car's motion, causing the car to decelerate. Example number 4. Once released, the glider moves at a near constant velocity as it experiences a nearly zero horizontal resultant force. Choose appropriate words to fill in the gaps below. A single force called the resultant force can be used to replace a number of forces that act on a body. If the resultant force is 0, then the body will either remain at rest or continue to move at constant velocity. Very important. If the resultant force is 0, then the body will either remain at rest or continue to move at constant velocity. If the resultant force is the same direction as the object motion, the object will accelerate. A car is decelerated when the braking force acts in the opposite direction to the car's motion. Changing shape. The force can change the shape of an object. A stretching force puts an object such as wire or spring under tension. A squashing force acts an object under compression. So a squashing force puts an object under compression. So what is tension? Tension force. A stretching force puts an object such as a wire or spring under tension. And a squashing force puts an object under compression. Brittle materials such as glass do not change shape easily and break before noticeably stretching. Resilient materials do not break easily. Resilient materials do not break easily. That means rigid body. Resilient materials do not break easily. Now elastic material. Elastic material returns to their original shape when the forces on them are removed. Plastic material retain their new shape. Stretching spring. Experiment. Place the weight holder only on the spring and notice the position of the pin against the meter rule. So this one is the actual length of the spring. Add 1 Newton or 100 gram to the holder and note the new position of the pin. Then calculate the extension of the spring by using this formula. Extension equal to new length minus original length. So remember this formula. Extension equal to is very important. Extension, sometimes we denote it by x, equal to new length minus original length. Original length is denoted by L naught. Repeat the stages 1 to 3 for 2 Newton, 3 Newton, 4 Newton, 5 Newton and 6 Newton. Do not exceed 6 Newton. So look at this experiment, an experiment to measure the extension of the spring. Same type experiment. Set up the apparatus as shown in the diagram. First, set up the apparatus as shown in the diagram above. A single mass 0.1 kg, that means 100 gram, is attached to the spring with the pointer attached to the bottom, and the position of the spring is measured against the ruler. The mass in kg and the position in centimeter are recorded in a table. A further mass is added and new position measured. The above process continue until the total of 7 masses have been added. The masses are then removed and the entire process repeated again until it has been carried out a total 3 times. An average can then be taken. Once measurement have taken, the force on the spring can be found by multiplying the mass of the spring in kg by 10 Newton per kg, the gravitational field strength, small g. So W, that means force can be found, W equals to m into gravitational field strength g. The extension of the spring can be found by subtracting the original position. So extension can be found equal to new length minus original length. Original length. That means extension equal to L minus L naught. Here L is the new length after application of force and L naught is the original length without applying any load force. Now typical result, this is the table. Position with holder only 450 millimeter. So added weight of 1 Newton, then pin position 480, so extension 30 millimeter. Then like this way, when added weight or force is 2 Newton, then new position will be 509, then extension will be 59. When added weight is 3 Newton, then new pin position is 541 and original length is 450. By subtracting, we can calculate extension 91 millimeter. When added weight is 4 Newton, then new pin position is 570 and extension will be 120 millimeter. Like in this way, we can also calculate the extension for added weight 5 Newton and 6 Newton. Now force against extension graph. Force against extension graph. Here remember when we plot a graph, then we should put extension in the horizontal axis. That means it is independent quantity. So here it is force, but remember it is the elastic force. elastic force. Elastic force. Because elastic force is the dependent quantity, not applied force. But remember, here applied force for a perfect elastic body, elastic force is exactly equal to the applied force or load force. That's why we can write in this way, or load force. So we get a graph like this. It is a force extension graph. Hooke's law states that extension of the spring is proportional to the force used by stretching the spring. So within elastic limit, extension of a spring is directly proportional to the applied force. That means extension is directly proportional to applied force. Because here applied force is the independent quantity. Applied force or load force. Load force is the independent quantity and extension is the dependent quantity. Or we can express Hooke's law in an alternative way. Within elastic limit, elastic force is directly proportional to its extension. So here elastic force is directly proportional to extension. Remember this one, very important, Hooke's law. We can express Hooke's law by the following two ways. One is extension is directly proportional to applied force or load force. Here applied force is the independent quantity and extension is dependent. On the other hand, and another way, within elastic limit, elastic force is directly proportional to its extension. So elastic force is directly proportional to extension. Now there is a question, mathematical question. A spring of original length 150 millimeter is extended by 30 millimeter by a force 4 Newton. Calculate the length of the spring if the force of 12 Newton is applied. So 12 Newton is 3 times of 4 Newton. So 12 Newton plus 12 Newton produces 12 Newton force of 4 Newton produces 30 millimeter extension. So if we apply a force of 12 Newton, then it is 3 times. So Hooke's law states that if force increases by 3 times, then extension will be 3 times. So therefore, new extension should be 3 into 30 millimeter. Very tricky. That's why Hooke's law is important. We can predict the extension if the object is perfectly elastic. So answer will be 90 millimeter. 90 millimeter. New spring length will be 150 millimeter plus 90 millimeter. So 240 millimeter. 240 millimeter. Now, what is elastic limit? Up to a certain extension, if the force is removed, the spring will return to its original length. The spring is behaving elastically, perfectly elastic. If the critical extension is exceeded, known as elastic limit, the spring will be permanently stretched. Hooke's law is no longer obeyed by the spring if its elastic limit is exceeded. The right hand spring has been stretched beyond the elastic limit. So elastic limit is the maximum force up to which an elastic body behaves as a perfectly elastic body. That maximum force is known as elastic limit. Force against extension graph if the elastic limit is exceeded. So here elastic limit up to this portion, up to this portion, the body behaves as a perfect elastic. So this force is the elastic limit. Elastic limit. Clear? So elastic limit, stretching an elastic limit and stretching an elastic band. Remember, elastic band does not obey Hooke's law. An elastic band does not obey Hooke's law because it is not a straight line. Force extension graph is not straight line. Remember. So stretching an elastic band give a curved force extension graph. So it shows the elastic band does not obey Hooke's law. Choose appropriate words to fill in the gaps below. Hooke's law states that when a wire or a spring is stretched, the increase in length or extension is proportional to the load force applied. This law is not obeyed if the spring is taken beyond its elastic limit, after which it will become permanently stretched. A rubber band does not obey Hooke's law. A graph illustrating Hooke's law will have a line that is straight and passes through the origin. Okay, no more today.